Welcome, everybody. Today we're working on Unit 4, and we're going to begin with talking about a bunch of different concepts, but the primary focus is to learn these three very critical commands in SQL, which are insert, update, and delete. And as they sound, it's pretty intuitive what these commands do. Insert adds new information to a database. Update changes the information, and delete obviously destroys the information. The one thing that I do like to point out to people as you start to learn database stuff, and I think this is really bizarre, because most of the time when we work on computers, our phones or tablets, our desktops, laptops, Mac or Windows, we're creating files using software. And when we're inside those files, we have like these great tools. Like, for example, if I type up a bunch of stuff in Word and I don't like what I did, and then I want to change it back to what it was, I can do Control Z, and I can do it a bunch of times and go backwards. Control Z, by the way, is undo, right? So meaning I could have created something, and then I could go step backwards, and then maybe I change my mind again. I'm like, well, actually, what I did do was better. Then you can do a redo and step forward. Like there's kind of like the safety net. And on top of it, like if I work, let's say in either Excel or Word, and the autosave feature is turned on, or if I'm working in Google Docs, creating a document or a spreadsheet, did you guys know that everything you do in those platforms, every version is saved? This is kind of neat, right? So like I started typing my paper, and then, I changed some stuff, but I didn't like what I changed it to. There's a revision history, and you can kind of step backwards. So it tells you like a little secret sauce about how that stuff works, that it's kind of, even though you're not doing it, it's making backup versions of all your stuff along the way, and can sometimes rescue content that you thought you destroyed. All right, those are documents on user operating systems. Guess what happens in a database, though, if you put in information and you delete it? Here's what happens. It is unrecoverable. It is gone, right? So when we get to the delete command, I'm going to get you to understand that it is completely destructive. And if you write your query wrong, and mind you, right, you write your query wrong, you can accidentally delete all the content of the table, right? It's not to add a little stress to what you do, but yeah, that's one of those things. So sometimes you proceed very, very cautiously with any command that changes content or deletes content, because it can be completely destructive. All right, so let's move along here and get into some of the topic materials. And I have a bunch of links here that I'm going to start reading through. And I do have my browser pulled up, and I'm going to copy my link from here so I don't have to hunt for it on their site. And so I'm following the first link, which is a create database command, which, okay, we're talking about destroying data, right? You can't bring it back. But one of the things that we are going to do here today is we're going to make a brand new database to experiment with, right? Rather than take one of the ones that's already existing and take the risk of messing it up. And actually, I want you to think about what I'm saying here, right? Like if you venture to do something that could be destructive, wouldn't it be better to practice on a different database or environment or whatever, however you want to think about it, before you try it for real, right? To practice it, kind of like having a dress rehearsal if you're a performer, right? So you have a way to kind of backtrack. Now, if you're going to create a database to play with, the command is super simple. And you see right up on the screen there, that you just say create database, give it a name and a semicolon, and it builds the empty skeleton of a database, is what that command does. So they'll give you an example here, right? Where they say create test database, and that's about all that's on this page, by the way, right? That's all it takes to create a database, is that one singular command. And we will do that. That'll be the first thing that we do when we get started, because I want to give you that experience early enough in the course where you can understand that you can build your own databases for whatever stuff you want. And I know like the first time I was exposed to database concepts, right? I mean, I had already seen documents, I had already kind of learned spreadsheets and saw their value. But a database is kind of an interesting thought because it's like, well, maybe you, I don't know, I'll just throw a concept out there. Maybe you have a big record collection, right? And wouldn't it be cool? Like, you don't know like all the records you have on the shelf. So you start making a database of all your albums. And who knows, maybe you can create an artist table and an album table and et cetera, and store information that's meaningful to you in that database. And maybe you have ideas about like, oh, it would be really cool if I could put all this stuff in a database. Now, what a lot of people do opt for, real frankly, is they'll just go to a spreadsheet because most people's information is pretty shallow, and I'm not trying to be insulting about it, but think about it. If I had a record collection, I could just put it in one table, right? Just like title, artist, et cetera, maybe even list the songs. But, there's an example right there. If I had a database for my record collection, I could have one table that just holds the albums, one that holds the artists, and a different one that holds all the songs. You could go down the rabbit hole with that for sure. But for most people, like I said, you can get most of it in one table. So once you create a database, now we have a secondary concern here, which is, all right, well, you just created a database, but there's nothing inside of it. So now we're forced to also create a table, right? Because we have to have somewhere to put the information. And in fact, you probably are going to end up creating more than one table because then, I mean, what you will learn, right, is information just because you can throw it in the table doesn't mean it's well formatted or organized. And one of the goals of a relational database system is to eliminate the redundancy of information in a database. All right, so let's look at the general form of doing this command. Once again, the command is very simple. It's just create table, and then you give it a name. Notice here the opening and closing parentheses. Not curly brackets, but parentheses. And then, of course, it's terminated with a semicolon. And then the typical format for writing a command like this is to indicate first the column name, whatever you're naming it, like first name, address, whatever, and then what type of data it contains. A lot of the data that we put in the database, real frankly, falls into one of two or three basic categories. It'll either be text of a given length, right? Characters, spaces, etc., or it'll be a number, either a counting number like an integer or a floating point number, with a decimal after it, or it also might be a date. And generally speaking, those are probably the four most used data types, right? Why? Because that most information falls into those categories. There are others, right? So today we're also going to do a little bit of a look at what data types are, just so you kind of get a little bit of grounding underneath you as we kind of build these. And let's kind of scroll down here and take a look at an example. So let's say we were building a database, and one of the tables we want to have in our database is people-centric, right? So we create a table called persons, right? Notice that we will put in an ID field, and we're going to talk about that more in just a moment when we talk about primary and foreign keys. But this is a really common thing that you do in databases. Often the very first column is some sort of ID field that makes that column unique. Okay, so for example, if I went into Gateway's database and looked you guys up as a student, what do you suppose your ID field would be? The student ID number, right? And then we use that for all your records. Like you use that as your login. If you're taking my web classes, that becomes like your password for your FTP account, et cetera, right? It's used for everything. But that way you have an identifier that's unique to you that travels with you as long as you're a person here at Gateway. What I do find really amusing is I have some of my instructors here who are graduates of Gateway. They went out and had a career for decades, came back. They still have the same ID number they had when they were students like 30 or 40 years ago. And I think that's pretty amusing, but the ID sticks with the person, right? So it's a unique identifier that identifies you. And think about why that would be. Okay, I have a really weird name. Like, I know for a fact there's probably nobody else on the planet that has the same first and last name and middle name as I do, right? Because my family doesn't have that many numbers. But what if your last name was Smith and your first name was John and your middle name was Mark? I bet you there's like 10 billion of those people, right? Well, not that, but it might even be a million people that have that same name. And out of those million people, maybe, I don't know, 500 of them had the same birthday. Wouldn't that be weird, right? And I don't know if you guys have ever been in a class. I think in my Python class tonight, I have like two Waynes and two Jonathans, and it's like, oh my God, try to keep them straight. So that's why we use IDs, right? Because it's a unique identifier just in case other information is repetitive. Isn't that kind of weird, right? But this is a very real kind of problem. The US government does the same thing with your social security numbers, right? And I think I told you guys last week that in the old days, that's what they used for student ID numbers, and it was printed on everything, including the envelope that would show up in your mailbox at home with your grades. They got wise and changed that. Now, let's look at this thing though. So the ID field is being named. We're saying we're going to name a field person ID, right? It will be of the data type int. Now, those that are taking a coding class, and I know some of you are in the Python class right now, that stands for integer, counting number, right? And so what we're describing then is that databases have what we call strong data typing. So for example, if I tried to type a word into that column in the database, it will reject it and fail. I'll get an error message and it just won't work, right? If I'm coding it in Python, it doesn't care, a not strongly typed language, it's like whatever, it's an integer. It just rolls with it. Databases, however, are the most finicky of beasts when it comes to data, and it's by design. And I want you to think about this. Would you want information in a database that follows you around like your whole academic career to be incorrect? No, right? And here's the reality as well, folks. When you're working with database structures, there's only certain people that really deal with the underlying code of a database. Most people interact with the database through an application. So somebody will create a web page or an app or a program that interacts with the database. And then that program will make sure that the data is in the right format before it ever gets to the database. So the database takes it without a problem, right? And these are important concepts, especially for those that are going to learn how to code applications, which should be all of you. Now, as we move down here, you'll notice that we have last name, first name, and look at the data format for that. This is a thing, and people say this different ways, but I call it varchar, right? Which basically is a collection of characters, and then inside the parentheses, the size of data that it can hold. So in other words, if I set last name to 255, I can hold up to 255 characters in that field. Okay, I will tell you, from old database experience, if I saw a number like that like 30 years ago, we would like freak out. It's like, no, it should be like 10 or 20, not 255. What's happened in the modern era, though, is our databases and our memory is cheap, and so we make things really big. I'm going to still say that's way too big. I would never make a database that would hold 255 characters for the last name, unless it's like for Kabir, Baja, BMU. Remember that guy in the Packers with the super long last name? So there are some people that have names like that, but I'm sure they figured out ways to abbreviate them. I'd say you could probably cap it at like 40 or 50 characters and be fine. The rationale, right, in the old days was storage space was very expensive. And every time I would make a selection as to the size of the information going into the database, I realized that, okay, well, if a person's last name is 5 characters long like mine is, but the field accommodates for 20, when I go to save that, I got 15 spots that are empty. right? So I'm not really filling my hard drive. I'm leaving a lot of white space, or blank space, if you will. And if you make a really large data size, like I think this one's excessive, then you're wasting that much space each time. So you're filling up a hard drive, but you don't have any information. Okay. Like I said, storage is cheap now. And a lot of people throw stuff on the cloud, whatever, and we don't care. We just build huge data centers that chew up power and whatever to store it. Like, who cares? But I'm going to say it's still a very relevant topic. The other thing that happens is if you make it the size it needs to be, then the database also operates more efficiently and more quickly and is much more responsive to the users running the application that's interfacing with it. So I'm going to argue that efficiency is still really important. So what numbers we set these for are pertinent. I would say, like, if I was doing this, I might set last name for like 25 or 30 and maybe first name for 20. And I would be comfortable with just about every name would fit in those spaces, right? There's maybe a few exceptions. All right, so then we move on and you see that we have a number of different ones. And what I think you'll generally see is that most database tables are predominantly filled with text. Now we get to some other specialized fields, and we'll talk about these, where what if I want to, let's say, build a database and I want to have like, and I notice here, this one stops at city. It doesn't say like state or zip code. But let's say I wanted to add like a state to this. Do I really need to use a bunch of characters, or could I actually narrow it down and just say 2 letters is enough for a state, right? Yeah, technically it is. And then there's a different data format for that we will look at. There's also data formats for dates, floating point numbers, and then in addition, we'll talk about the example of adding other values like the primary key information and whether or not we require information to be in there or not. This is kind of also an interesting concept, right? So for example, if I was putting you guys in the student table with your ID number, I would say that the ID number could never be blank. And I would think first and last name would be that way too, but there are people that don't have last names or first names. They have like, symbols for their names. That's a very real thing. And I was just having a conversation with somebody about it the other day, which I thought was kind of weird. All right, let's now take a look at data types and explore some of the different possibilities here. All right, so in essence, what a data type is a column that basically, like a data type for a variable in programming, designates what can go in that column. And notice like the things that are listed there, an integer, a character or collection of characters, financial amounts, dates. We can also store time. We can store binary information. And what you'll learn is there's even more things that you can throw in there when it comes down to it. But most of the time, it's going to be numbers, dates, and characters. So here's some of the data types. And I want you to notice this is broken down into categories here. So the first thing we're going to look at are string data types. And then there's numeric data types. And then there's date and time. And then there's actually another category that mostly they're not showing here, but that's okay because it's kind of advanced, right? A lot of people don't use it. But let's look at the string data types first, because normally we think of like words going into a database. And in reality, the data type for strings that you're going to use, I'm not going to say exclusively, but almost exclusively, will be the second one on the list here, which is varchar, and the size to go with it. So I want you to notice what it can contain, because the thought is, well, it's just going to be letters. Okay, wrong. You can also put numbers in it and special characters. I'll give you an example. A lot of people, when they do phone numbers and they put them in a database, well, it's a number, right? So I'm just going to I'm only going to allow numbers. But what if like you type in your number, and you've probably done this on a form online or something, where you put in your phone number and you put in dashes or parentheses, and it's like, must be a number. That's like, no, right? That should be kind of your reaction. So like if you were doing a space for a phone number, how many characters would you give it? I want you to think about that for a second. Well, area code is 3. Then there's a prefix and 4 numbers. That's 10. Throw in a couple of parentheses. That's 12. Put in a dash. That's 13. Put a space after the parentheses. That's 14. Throw in an international country code, which is 3 letters and a plus sign. And we were up to almost 20, right? But it's characters, and you could put all that stuff in there, right? So I would recommend for phone numbers, don't use number. I would use varchar instead of 20. And that should accommodate any phone number, by the way. Some would say, okay, take it up to 25, they can throw in an extension number, and that might be valid as well. So this actually can be set to go from 0 to 65,535. So that's a lot of characters, right? That is, and by the way, those are powers of 2, is what dictates that number. So a variable character can hold a lot of information. It's probably the most flexible of all the data types too. So just be mindful of that. Another one that is very useful, and I gave you guys the example of like if I was doing a state and I just wanted a 2-letter code, I would probably switch to this data type, which is character. And then notice this can also have a size dictation, but look at the biggest size you can go. 255 is the biggest, right? The default is 1 if you don't declare it, right? And this is kind of interesting too, right? The fact that there's a default. Okay, so what would be a situation where you use just a character field? Well, how about a middle initial as an example? I would say with the middle initial, some people will put in the period, so you might want to make it 2. And some people have multiple middle initials, so you might want to make it 10, something like that. But these are things that you think about as you're doing it. I think like states are a good one to do, like character size 2. I can also do it with varchar and make it size 2. Same difference, honestly, whichever one you're comfortable with. I want you to notice there's some other really weird ones. Like if you have other formats, like if you have like really long text, right? You'll notice that there are data types that allow for it. So like there's long text, and I want you to notice how many characters that holds. It's like 4 billion characters, 4 billion characters, right? So that's a lot of characters, right? Then there's these weird ones like blob, but these are for binary objects, right? Which we're not really concerned with at this point. But what that means is I could take like binary information, like an image, for example, and drop it into a field like that. This gets kind of complicated. But you notice a lot of these are variations on each other. Like tiny text is really like character. Text is really like varchar, right? And I consider these kind of antiquated in their approach, right? So generally speaking, I think generally you're going to be using these top 2 almost all the time when you do text. The exception, I think, would be long text or medium text. If you know somebody's going to like, I don't know, like a social media post probably goes into something that size, right? Where they can just, you can type and type and type and it holds all of it. Another really weird one, and these are, once again, advanced skills, are enumerations and sets where we have collections of values listed. And this gets a little bit deeper conceptually, but basically where you have a list of information within one field. Right, let's move on to the numeric data types because there's a number of these as well, right? Thanks whoever designed this for making it so complex, right? Let's start with the most basic one, which are integers, right? And you'll notice here, it's down on the list here, and I want you to notice that it's got 2 different formats you can write it in. You can either use the int, which is the more common one to use, or you can spell out the whole word, integer. Int, I think, is kind of the go-to, and I want you to notice a couple of things about this data type. It'll hold assigned range. So it'll hold negative numbers down to whatever that is. I don't know if that's 2 trillion, whatever, negative 2 trillion up to positive 2 trillion, roughly, right? That's pretty large capacity for numbers. Um, if you go unsigned, in other words, there's no negatives in that column, you can flip that to go up to a positive 4 trillion or whatever that is. The size parameter, it says here, specifies the maximum display width, which is 255. And I want you to understand there's different than the actual capacity. So I have a really large number. That's just how much it will display on the screen. So like, let's say you're looking at like phone numbers and you only want to look at the area codes, so you can declare the size. You're only looking at the first 3 characters, for example, but not the rest of it. I don't know if I would ever do that, but I'm just trying to think of an example where you might. So there is a size thing that you can throw in. Generally speaking, though, we don't use that. Usually we just say it's an int and just walk away. If we know the integer is going to be small, like, for example, less than 32,000, right? Or between negative 32,000 and positive 32,000, I could use a small int. Why? Because it uses less memory in the database, right? Do coders generally use this? The ones that are smart about memory usage and storage do, right? But a lot of people generally just kind of skip it. And what's happening these days in database systems is some of that is dynamically allocated anyhow. There's also the medium size one, right? And you can see the range there. And then of course, there's a big int if you need really, 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 really big ones, right? Like you're doing like scientific stuff or something. Those, I don't even know how many, that's probably like our national debt or something. Just ridiculously huge numbers. All right, the other main format is what we call float or double or decimal. Now, for those that have studied, let's say, Java programming or C# programming, you will recognize these as data types within a traditional compiled programming language. Overall, which one of these you use really kind of depends on kind of your practice and what you're after. A lot of times when we do financial things, we will use decimals, and here's the why. We can have an exact fixed point number, right? And if we want, we can specify in its size and the number of digits after the decimal point that will be stored. So for example, if I'm storing prices for products, I can set up a field that stores 2 decimal places. Makes sense. Now, if I'm selling gasoline, I need an extra one, right? If I'm calculating, I don't know, something much more precise, I would need to know what the precision is. But all of these, if you notice, have that capability. I want you to notice also that float is basically what we call deprecated. This is an important kind of computer term. Deprecated means it still works, but really you shouldn't be using it anymore. Eventually it will be removed, is what they're saying. So a lot of times deprecated stays in place, deprecated commands stay in place. Why? Because we have old databases that are still running. And this is kind of scary stuff to think about, but most of like our banking system here in the United States, the databases were built in the 70s and 80s, right? So if we turn off that code and shut down the deprecated commands, we can't bank. I think it's really pretty weird that we use databases that old. Why do we keep using them? They work, right? And if they're working, you don't touch it. It's like if your car keeps running, right? Why shut it down? All right, so float's one that you should probably stay away with. And I want you to notice the difference between a double. So this is, they call it normal size, and it will kind of automatically adjust to things. But if you need an exact fixed point number with decimal places, the decimal is kind of the way to go. Right, so you'll see both of those in play, but those are the common numeric formats. If you go up to the top here, they also have bits and tiny ints for really small values, right? So bits do 1 to 64, tiny int does 0 to 255, and there are times where that's perfectly fine and enough. And then we also have the Boolean values, which we will end up using too, which essentially just hold true and false. You know, is good customer true? You know, that type of thing. All right, so those are the data types that we're most concerned with. It's text and numbers, but it is also important to note that we do have date and time data types as well. So these can be stored in a number of different ways. And I think probably the biggest takeaway from this little piece of information is the actual format of how dates are stored in a database versus how we write them as human beings. Like if you go to a website and they say, enter your birth date, how do you put it in? Well, you usually go month, day, year. And then the Europeans who'd listen to this go, you guys are doing it all wrong. It should be day, month, year, right? And that's how the Europeans do it, and most of the rest of the world, by the way. But from a numeric standpoint and sorting dates, the best format, and this is why databases use it, is they put year first, right? And you see that here, year first and 4-digit year, 2-digit month, and then a 2-digit date. And so a date is stored in that format. So that's how it's written into the database. We did talk about this briefly last week because we did a little example of it, but just to reinforce that. So when I use the data type date, it just stores year, month, day, right? There's also a format that's called date time, where it does the year, month, day, and then hours, minutes, seconds in that order, in that format, right? And so like information that might be in there might look something like that. There's also a timestamp. So a timestamp you can actually drop into a database. So like the moment, let's say somebody signs up for your website and they get into your database, there's a timestamp that goes on that with today's date and time. So you can look back and go, when did you first sign up? And there it is, right? And that is automatically generated, or what we call initialized, basically, by the database system. So it gives you the current timestamp, right? If you're just looking for the timestamp without the date, you can do the one below, which is just time. So it just records the time. And then you can also just store the year, right? And even though the year looks like an integer, it's treated differently in the system as a data type and the way it handles things and does actions within the database. So those are our data types. All right, so from here, let's talk about primary keys. And we've kind of, I guess, alluded to this a little bit already. But let's talk about what a primary key is for a database table. So the primary key, and notice the word constraint here, right, because this is maybe our first exposure to this word, uniquely identifies each record in a table, right? This is what we were just talking about. So when I look at the student table in the gateway database, your primary key field is your student ID number, right? For all the reasons we explained, right? Because it is possible that we have multiple students with the same name, even the same birth dates. Heck, they might even live on the same street. That would be very, very odd, but weird things happen, and the more humans you have, the more likely that is to happen. The interesting thing about a primary key is it has to contain unique values. So in other words, I can't create another record in my database, use your student ID number and put a different student name on it. It won't allow it. Because it's the primary key field, it will reject that information. It's got to be unique. It's also important to note that this concept of null comes into place. Do you guys remember what null means? It's like the absence of everything. It's not zero, right? It means there's no information in there. So a primary key, if it uniquely identifies a record in a database table, can never be empty. So it cannot be null. So when we create a primary key, that often is a nomenclature we use too. We use the keywords not null to say that it's not allowed. A table can only have one primary key, so you can't have two. You can't say I want the student ID number and my social security number to both be primary keys. No, not allowed. That's not okay. Right? It can only have one. Um, but okay, so here's the caveat to that. You can have your primary key consist of more than one column. So you could take the ID number and combine it with something else, perhaps the last name. So you can use multiple columns to make a primary key. I'm going to say that most people don't do that, but I've had a couple of situations where I built databases where I did do that because it was logically necessary, at least in my mind. Right. All right. Let's take a look at a couple different approaches for declaring primary keys. So we have this table called persons again, and notice that we did create an ID field. We're going to make it an integer, and we've already said it cannot be null, meaning cannot be left empty. All right. And then down here at the bottom, we use this command, primary key, and then inside parentheses, we're indicating which column is the primary key. That is one approach. Okay, so here's my little caveat. It's not my favorite approach for doing this. Although this is kind of like the language standard. What I normally do when I'm creating a primary key is right here after it says not null, I'll just say primary key. And then I can omit the parentheses. And that way the declaration is right there, right off the bat. And just to give you an example here, because we're going to be doing this in the homework later, here's a table I'm creating, and I have a student ID, an integer, it's not null, and it's the primary key all in one line. That's what I'm talking about. So that's the alternate approach to doing it. And frankly, my preferred way to do it, because that way I see it right away. I don't have to wait to get to the bottom of the description to find it. Right? But, I just want to, put it out there. This is also a workable approach. If you wanted to do a primary key across two columns, notice how they're doing that. And this is not a technique that we're necessarily going to use, but just in case you wanted to do it, let's say you wanted to take the ID and combine it with the last name. That's not an uncommon approach, but I think just the ID approach is better. But if you wanted to do that, you have to include the keyword constraint, name it basically a new name, which is basically the combination of those two columns. So primary key person is what they chose, and then call that combination the primary key. This is not something we're going to do in our homework, by the way. If you want to add a primary key to a table that already exists, you can actually declare it after the fact. We haven't learned the alter command yet, but for right now, our primary approach is really to build it, not to change it or add it later. It is possible to also remove a primary key if you wish to do that, and I'd say this is a high-level action, because usually once you build a table and it's working, you don't want to really change it. Right? It's during the construction process that you might use these last two commands. So our approach will be the ones that we see here. The other concept that becomes kind of important is this concept of a foreign key. So a primary key relates to the table you're working on right now, having an ID field that's unique to that table to make sure every record is unique. Right? A foreign key, and just read what it says here. It says, the foreign key constraint is used to prevent actions that would destroy links between tables. It's a field or collection of fields in one table that refers to the primary key in another table. So for example, if you were a student taking a class and you have an ID number in the student table, and then you go to register for a class, they're not going to copy all your personal information and demographics into the registration table. They're just going to grab your student ID. But in order for you to validly register for that class, that's got to be a real primary key in a different table. So that's why we call it a foreign key. So the constraint is I can't register you for classes unless you're already a student. Doesn't that make sense? Yeah, that's the logic there. So your ID field from the student table becomes your foreign key in the registration table, right? Now, some terminology that goes with this. The table with the foreign key is called the child table, and the table with the primary key is the reference table or parent table. I will be frank, I never use that terminology, but some people do, right? So here they're showing an example. Here's the persons table, right? So we have a few different people there, and they have their IDs, and then they place an order. And once again, we don't repeat their personal information, right? That's inefficient database design. We just use their ID number, and then as long as if this is a primary key field that has to be unique, then it becomes a foreign key here because we don't want to give an order to somebody that's not an actual person, right? So that becomes a foreign key, right? So I think I've kind of said all that stuff. So here's how we declare primary key, and here's how we declare a foreign key. Now notice the layout of this now. So we say foreign key, we indicate which one of these is coming as a primary key from a different table. And in this case, it would be the person ID from the persons table. And it tells you which table it's referencing. So it's telling you that it's referencing this column. The column would be inside the parentheses from this table. And of course, this has to be a valid primary key in order for the foreign key to work. But notice the terminology here, and this syntax, this is the only way you can do a foreign key, by the way. When we get into MySQL Workbench and we start to look at the table layouts, you will notice that primary keys will be bolded, and foreign keys, I think, are also bolded. I forget how they do that in the schema table there, but you can tell that there's that connection. And folks, it is these types of primary and foreign keys, especially the foreign keys, when we start to link tables together, that drive a lot of relational database stuff. Right. You can also do this as a constraint. Right, so look at the rewrite, especially if you're doing multiple columns, if you need that. And normally I'm going to say that's more unusual. So this is the approach we'll use most often. They show you ways to add foreign keys after the fact. That you might do. You can also remove a foreign key as well. And that's another one of those you might do, but typically I call those higher end actions for sure. All right. I think we talked about null values enough, so I'm not going to revisit that. But now let's get to the primary commands that we're looking at. And once we lecture through these, we'll take a break and come back and do some coding. But just 3 more commands here. So let's take a look. So insert, update, and delete. So here comes insert. And then I want you to notice that insert, even though we just say insert, the command in full is insert into, right? So it becomes a little bit more English-like. And I want you to notice the syntax here, right? The insert statement basically is the command that we use anytime we're entering new information into a database. So you can imagine this is a really common command to use. Think of the scenario where, like, once again, you visit a website or you're running an app and you sign up for something, right? And then you hit submit and something happens, right? One of the things that happens is there's probably an insert into command somewhere that's like insert into customer table or insert into student table, your information, and we've just added a record to the database. And the syntax here, there's alternate syntaxes for how to accomplish this, and this is pretty important in terms of like how we lay it out. And so, like, notice the first one here, and these are very subjective in terms of what layout you prefer to use. So let's explain that first. Most often when I'm doing an insert into command, I use this first approach, and that's just kind of the way I was taught and what I'm comfortable with. So like if I'm writing like, let's say a Java program or something that's doing SQL commands within it, this is what I would use. So basically you use insert into, select the table that you're dropping it into, and then you list the columns that are affected, right? In order that you're going to send the data. So maybe it's like ID, first name, last name, right? And you list all the columns that you're dropping information into. Mind you, it doesn't have to be all the columns in the table. It might just be some of them, or it might be all of them. It depends, right? And then we use the values keyword, and then in the order that the columns are displayed, we put in the values. So this might be an ID number. Maybe that's auto-generated, by the way. This would be the first name that goes with column 2. This would be the last name that goes with column 3. So in other words, the order that you list the columns, the information you're sending in has to match. If you like flip first name and last name, they'll still go into the right place as long as you put them in the right place down here also, right? So you don't have to follow the column order of the table, but more often than not we do, right? Because why? Because it's easier, right? But you don't necessarily have to. All right, so look at scenario number 2 here. If you're adding values for all the columns of a table, you do not need to specify the column names in the SQL query. However, make sure that the order of the values is the same as the order of the columns in the table, right? So if I'm doing ID, first name, last name, address, city, state, zip for every entry, I can skip the column names. It's implied. I just have to make sure that I'm sending in the right amount of information. So both of those approaches can be used, I think, pretty successfully. I tend to be more comfortable with the first approach because I can see it on the screen and my brain is more comfortable with it, right? But experienced SQL programmers often bypass that. I have some examples here, right? And so they're going to insert into the customer table, cardinal, here's the name, the address, the city, postal code, and the country. Notice how that goes. Very commonly used command, folks, over and over. If you did just want to insert information into certain columns and not fill out the other columns, like for example, maybe you don't know the address. Maybe you don't know the contact name. You can cherry pick which columns, but the column order and the value order still have to match as you're sending it in. All right. Next command we're going to look at is update. And in this case, once again, this is, I think, pretty intuitive, right? We use the update statement basically to take a record in the table that already exists and change it. So let's say you're a student here at Gateway and you move. So now we have to put in a different address, city, state, and zip code. Or maybe you got a new phone number, or maybe you got a new email address, right? Or maybe you got married and your last name needs to change, that type of thing, right? So we're not deleting you or your ID number, but we're just updating certain parts of the record. So we'll indicate which table it affects, and then for each column that we want to change, we set the value. And notice the different approach here, right? So we list the column, put it in an equal sign, and the value that it's going to change to. And that might be one item, or that might be multiple items. We also often throw on a condition statement to make sure that we're, not changing everybody's address to the same address. So this is like the caution, and that's the yellow box. Be careful when updating records in a table. Notice the where clause in the update statement. The where clause specifies which records should be updated. If you omit the where clause, all records in the table will be updated. Not good, right? So like, hey, I changed my name to Smith, and I skipped the where condition. Everybody in the database now has the last name of Smith. Not good. So we really got to like narrow down your stuff. So here's an example, right? So we're going to update the contact name for somebody in the contact table and their city, but only where the customer ID equals 1. So usually you get very, very specific like this when you do updates. And folks, you got to be really careful with that. Some database systems have roadblocks in place to intentionally block those kind of actions because, man, that could be really, really destructive. Right? You can imagine that. Right? And once again, this is when we get to update and delete, these are, I would call these like higher level database actions. It's not that you can't program around it, but especially the engineering of it has to be done very carefully. Right, so that's the update. You can also update multiple records. So okay, so like you guys know with a where clause, sometimes you can pick one particular thing, but maybe you update all the customers from Mexico with the same postal code. And I don't know if that's a valid postal code for Mexico. I'm assuming not, because maybe they don't use postal codes in Mexico. I really don't know. Right, so you can kind of do a bunch of them together. And remember the warnings here, right? So this one would set everybody's postal code in the database to all zeros. Not good, generally. But maybe you have a reason for it. I don't know. I can't think of one, but maybe you do. All right, last one that we're going to cover here before we get into coding, and that's the delete statement, right? As it sounds, we use it to remove a record in a table, right? The syntax is basically pretty simple. We delete from, so we insert into and we delete from, right? So those two words go together. We list the table and then we indicate a condition, right? Warning once again, it says be careful when deleting records in the table. Notice the where clause in the delete statement. The where clause specifies which records should be deleted. If you omit the where clause, all records in the table will be deleted. Double underline, highlight red, whatever, right? So if you just say delete from table, skip the where clause, everything's gone. Okay, maybe there's times that you want to do that, but they actually have a separate command for that where you can drop a table, just get rid of the table and just rebuild it. Maybe you don't want to do that. Maybe you do want to clear all the data out. Maybe there's a reason for it. I'm going to say that's highly unlikely though, but it's not unlikely that like if you were, let's say, a student in our database here at Gateway that after 20 years or, maybe you expired or whatever, you're not coming back as a student. So yeah, we can delete your record at this point, because we're never going to look at it again. I don't know if that's true at Gateway, but it might be true for a customer database, or it might be true for other types of databases. Example really quick on this. And I think this is a nice simple example. Delete from the customers table where the customer name equals this, or where the customer ID is this, and then they're gone. Or maybe you have a product database and that product's no longer manufactured. It's never going to be built again. You don't want it to show up on your e-commerce platform, so you delete the product. It is possible to delete all records. You just say delete from table name. I think we talked about that. No where clause. They're highly destructive and one to be cautious with. All right, folks, this completes the lecture materials for Unit 4. And this video ends here. We'll come back and do some coding.